usually notation is to, just to be sure that I'm talking about the area and not the triangle, I just put like vertical bars on either side, like absolute value of the same vertical bars. Okay, can you see why that's true? Okay, sure, I can put a triangle in front of it. Okay, so area of AFG, which is that one, divided by the area of BFG.
They have a common height.
Yeah, pretty much what he said. So they have basically the same base here, and if you drop G down, call that H, they have the same height. Cool? So, for example, area of triangle AFG will be half. Your base is AF times your height, which is H. We're just calling that height H. And then the same thing for BFG is half BF times height. And when you divide the two, you just get that cancels and you're left with the ratio of the areas. Cool? So that's true. Now, this AF over FB is also equal to area of triangle AFC over the area of triangle BFC. And why is that true? Someone from that side. Oh, yeah.
Isn't it the same reason because the height is the same?
Yeah, pretty much. So it's just the same thing with G replaced by C. Cool. Now, the last one, where we're going to combine these two, is maybe a little bit more tricky. AF over FB is equal to area of triangle AGC over the area of triangle BGC. Okay, so this is now this triangle divided by area of this triangle. That does not help. Anyway. Just posing for the camera. Okay. Do we have any ideas as to why this is true? We have to use these two and combine them in some way to get that.
I'd say it's because area of triangle AFG is equal to AF times by some factor x, and BFG is equal to FB also times some factor x. And you know, with the AFB times FB, it's just with y. So each time the area of the triangle is basically a multiple of the side length. So therefore, you can subtract the two.
Okay. Cool. That's one way of doing it. Yeah.
If you take triangle AFC and if you were to take out AFG, then you've got the area of AGC.
Mm-hmm. And then it's basically the same thing on the other side. So basically, those two ideas is how you can prove this. How to do. So basically from this one, so area of AFC, so that's area of, so that's AFG plus the area of AGC, area of BFG plus area of BGC. Cool. So we take the big one and we split it into the smaller ones. Now, what we do next is we take that this is equal to AF over FB, and we cross multiply. I don't feel like writing it out. It's not enough space. Anyway, so you cross multiply out, and basically you have area of BFG times AF and area of AFG times FB. Because of this relation, basically these two terms disappear. So you multiply out, you cancel something on each side, and then you divide again to get this one. Okay, you can do the algebra yourself. I would do it, but just there's not a lot of space on the board right now. Cool. So now, why is this pretty much like we're done with the question now? What if, so this I just did for the one side, I did this for AF over FB. What if I was to do it, so do the exact same thing for BD over DC. What would I get at the end here? What would I get on this side? Say that to the ladder.
If AG over GMC or the other way around, I'm not exactly sure.
Wait, sorry, say that again?
If AG and GAC.
Do you mean BAG? I think you mean BAG.
Oh yeah, sorry,
Yeah.
BAG.
Okay, so on this side we have area of triangle BAC over the area of triangle, let's do, I don't know, CAG something. Okay, and what if I did it for CE over EA? What do I get? Turn the volume up.
GAD over GC.
G what? Over. Okay, so CE over, it's actually the other way around. Yeah. Okay, so area of triangle GBC over the area of triangle GAC. Cool. We don't need that anymore. So, what happens now? Okay, you multiply all three and you just prove it. I don't know how you just prove it, but apparently you just prove it. Okay, AF over FB times that over that, BD over DC times that over that, CE over EA is equal to, you guys don't mind if I go like low here, you can still see. Okay, cool. So AF over AB, let's write it this way, GCA over triangle GBC, and that's times triangle over there. Wait, that's not BAC. BD, and that should be BAG. There we go. So triangle GAB over area of triangle GCA times